A second feels like the most basic unit there is. Tick, tock, done. But who actually decided how long a second is? For most of human history, nobody agreed. Settling it took 4,000 years, and one very strange atom. Today, no clockmaker, no king, not even the Earth sets the second. It's set by something vibrating inside a single atom. Over 9 billion times every second. The story starts in Babylon, where astronomers divided the sky with base 60 math. An hour became 60 minutes, and a minute 60 smaller parts. Elegant math for something nobody could actually measure yet. Sundials died at night, water clocks froze, dripped and drifted. For thousands of years, the second was a rumor. For centuries, the second stayed theoretical. No machine could track it. Then, in 1656, Christiaan Huygens built the first pendulum clock. One steady swing became the most accurate tick humanity had ever made. Suddenly, seconds weren't math anymore. They were hanging on your wall. But the pendulum had a hidden flaw. It was only as steady as the planet it swung on. Huygens' clock drifted about 15 seconds a day, a miracle for its era. For nearly 300 years, the official second was a fraction of a day. 1/86,400th of a single spin of the Earth. Simple, logical, anchored to the most reliable clock imaginable, the planet itself. Astronomers timed the stars to keep the world's clocks honest. Except the planet isn't reliable. Earth's spin is slowing down as the moon's gravity drags at the oceans. Every day stretches by a tiny, uneven fraction of a second. By the 20th century, physicists knew their perfect clock was drifting. The perfect day was quietly lying by milliseconds. If the second could bend, every calculation built on it carried hidden error. Navigation, astronomy, engineering, all of it. Science needed a clock that answered to nothing on Earth. By the 1930s, quartz crystals ticked 10,000 times steadier than any pendulum. But quartz still had to be checked against something, against the sky. In 1955, at a British lab, Essen and Jack Parry built something radical. A clock that didn't swing, spin, or tick. It counted the vibrations of a single caesium atom. Every caesium atom in the universe vibrates at exactly the same frequency. No weather, no gravity, no where can change it. A pendulum that never winds down and never lies. It took a decade of testing before the world trusted it. By the 60s, the atomic clock had outperformed the planet itself. So in 1967, at the General Conference on Weights and Measures, it became official. The second was permanently redefined. Exactly 9,192,000,000. 631,770 vibrations of caesium. Not a fraction of a day, not a swing of a pendulum. A number counted inside an atom. That number is now the invisible clock underneath your entire day. Your phone has no atomic clock, it just borrows one constantly. GPS satellites each carry atomic clocks, ticking in orbit right now. Einstein's relativity makes those orbiting clocks run fast, by microseconds a day. Left uncorrected, GPS would drift by miles every single day. Stock trades, internet packets, power grids, all stamped in atomic time. Earth still wobbles, so leap seconds occasionally patch the sky back to the atom. 27 leap seconds have been added since 1972. And the second is about to change again. Optical clocks now beat caesium's precision 100 times over. Metrologists plan to redefine the second once more, around 2030. The planet spins however it wants. Time now belongs to physics, because someone had to decide.